I am hanging out and talking with Jake from Millennium Machines about the new BTT Scylla or Scylla control board
I
for CNC
yeah
mills.
yeah I believe it's technically meant to be pronounced Scylla, but I say Sila. So pick and choose your own adventure, folks.
Absolutely. So, this is really interesting because if we look back to the initial release of the Milo 1.5 that came with the Mellow Fly board, was CDY3, I
Yeah,
believe.
the Fly CDY V3.
Yeah, which is essentially a 3D printer MCU, which got repurposed for the mill since it can run RepRap firmware, which has a CNC mode. But this is a control board that is specifically designed for milling that your team worked with BigTree Tech on.
Yeah, depends on what you mean by worked. We gave BTT all the specifications, and it was initially brought to us by LDO. LDO wanted to make a board for us, and then they set us up with the guys from BTT, and we gave them all the specifications. And by we, I mean 9 Mile did, because 9 Mile did most of the work on Sila, and I don't want to take the credit away from him. He did an absolutely brilliant job with it. Um, so we kind of realized early on after the V1.5 release that if we wanted to run things like Moss or arc movements or things like that, we needed a whole lot more memory for the from the MCU side of things, because it would constantly throw low memory issues. And when you're looking through back then, when you were looking through what boards were available, um, the Fly CDY was just it. It didn't meet every requirement we had, but it was the one that was the closest to meeting all the requirements we did have. Things like running RepRap firmware, having drivers that were technically powerful enough, um, and having a whole bunch of IO pins that were easily accessible and easily changeable through RepRap firmware was a big thing for us. Like we said, we quickly started running into issues around it. So Silo was born. Silo was made specifically for CNC in mind on RepRap firmware. It does technically have the ability to run Gerbil HAL and Linux CNC, although those are a lot more involved setups, more involved than the typical person who who 3D prints and does CNC stuff on the weekend would be willing to do. Is kind of what we the way we describe it.
Yeah, it's looking at the two boards. There's a world of difference in capability. I mean, just off the top, as you said, this is running one of the newer H7 processors, so it's a more
Yeah,
capable processor right from the get. Then it's got more memory. And to clarify, just in case people aren't familiar, MOS is the Millennium Operations System, which is a system of macros and graphic overlays that rides on top of RepRap firmware to make the system much easier to use and more approachable. At least that's been my experience.
yeah,
Um,
yeah. That's definitely one of the layers to MOS. Um, MOS is it's more designed to take RepRap firmware, which is essentially a 3D printer firmware with a little bit of CNC on the side and making it a fully functional CNC interface. And then there's also, like you said, making it very easy for newbies. So it just makes the whole process of running a CNC through RepRap firmware a lot easier.
yeah. But aside from the sort of computational bits, it has four 2160 stepper
Yeah,
drivers, the board has multiple voltage rails, so motors can be fed up to 60 volts. So
Mhm.
you're going to get much better performance out of the NEMA 23s that are on the Milo.
Oh
Um,
yeah,
yeah. So you've got
yeah. One of the
that.
ish.
Oh, go ahead.
So go ahead. Well, yeah.
No, I was
One of the issues. Oh, sorry.
you.
You go. You go.
No, no, it's you.
Okay. Okay. One of the issues we had with the Fly CDY is that if you're using 2209s, the 2209s could go to a peak of 2 amps RMS. Sorry, a peak of 2 amps, whereas a typical NEMA 23 is between 2.4 and 2.8 amps, right? So you're only getting so much performance out of the NEMA 23s when you're running them on 2209. And there were some weird current limitations on the CDY board as well. So if you did run the 5160, just the Palulu style ones, if you were running one of the 5160s, there's a good chance you'd end up burning up the traces on the board if you're running them at the currents that they actually needed. Um, so that's obviously not something you want to do. You never want to release the magic smoke. So yeah, the 2160s allow us to drive up to 4.7 amps RMS and 6 amps peak. But you also have to keep in mind that throughout the entire motor rail, you can only get a maximum of 10 amps out of it. So if you're running four motors at 2.5 amps, that's the maximum you can get out of that, for example.
Okay. But definitely much better capabilities than
Oh
we
yeah,
had on the
yeah,
CDY. Um,
yeah.
better communication. Certainly, the CDY required, excuse me, the CDY required an expansion board
Mm,
for a lot of interfacing, including a PWM to variable analog voltage for spindle control. All of
mm.
that is now moved into the Scylla board, as well as support for CAN and RS-485.
Yeah, RS-485 it's a tentative one to talk about because RS-485 is implemented very differently across every different kind of VFD. RS-485 is a standard that no one really adheres to properly. So Nine's been doing a lot of work in the background with RS-485 and Modbus to try and get it working across a whole range of common VFDs. So things like the Xilen VFDs that we have from the LDO kits, the Huanyang VFDs that you get from just general hobby shops, things like that. So there is some work going on in the background. Luckily, all VFDs support either 0 to 5 volt or 0 to 10 volt, and some of them even support just straight PWM. And like you mentioned, all of that has been moved on board, and you don't have to have a separate daughter board for it now. And that also includes the relay that was on the LDO board.
Mm-hmm.
So you can now control. There's now a a full-on controllable relay on the board itself, as well as a few controllable MOSFETs. So
So
that
that relay is for the spindle enable.
no, the spindle enable is run by a dedicated MOSFET now on the board.
Okay.
So that's dedicated. It's part of the wiring terminals for the spindle itself. Um, we're currently at this point of development for the electronic side of things. We're not using that relay for anything. So you could hook it up to pumps, you could hook it up to solenoids, you could hook it up to airlines, things like that, if you so wished. We are potentially thinking of using it as an extra layer of safety, which we'll talk about. We can talk about it later, but just the broad overhead is that it uses software to break the line of the e-stop. So even if you press the e-stop after you've had to do an emergency stop, you would still have to let the software the software would then prompt you to enable that relay, thus completing the circuit again. So it's like a double e-stop kind of feature that we're potentially going to be adding, but we don't know whether or not it's needed at this point in time. We're still evaluating the safety aspect of that.
Okay. So if you hit the emergency stop, the theory would be that then you would also change the state of the relay so that even if the e-stop was reset to provide power to the VFD and the motors, that
Yeah,
you would still have to go into the software and say, no, really enable voltage.
yeah, exactly.
Okay.
So basically we're trying to fall into industrial standards of operations before, whereas before on V1.5 we would just cut all power, right? And you see that a lot on drill presses and lathes and things like that, things that don't have a brain controlling them. And we still do say it's a pretty safe system on V1.5. We're just trying to move to more industrial standards of operations, and that means shutting down systems in what are considered safe states. Um, so, like you mentioned before, there's multiple different rails for input power. There's three. There is voltage for motors, voltage for the MCU, and then voltage for the MOSFETs. And for example, the way we're going to be setting it up, when you hit the e-stop is going to be two poles. One of those poles goes to the board, does a firmware e-stop. The other line goes to a contactor, and that contactor breaks connection to the power supply that runs the motors and the VFD. So when you hit that e-stop, the motors will lose power and the VFD will lose power. Now, if you don't have that backup software e-stop going, the moment you turn that e-stop button off again, if you haven't paused the operation that you're doing, the machine could still be live and still be moving and still be taking G-code commands. So you need that extra line just to make sure the user knows that there's a potential that that if they haven't reset the machine properly, that machine can still be live. Yeah,
Yeah.
hopefully that made sense.
No, no, absolutely. Because, depending on the failure mode, you could
Yeah,
be in a scenario where the machine needs to be emergency stopped. You e-stop it, and then when you re-enable the e-stop for operation, the machine could jump back into doing whatever
exactly,
it was
exactly.
doing. So this way, even though you're restoring power, there's no commands going to any of the motors or the spindle.
Yeah, and because we can do that at a startup level, so even if the whole board lost power completely, that relay would be in a normally open state anyway. So it gives that redundancy in the system. Whether or not we need that redundancy because we've already got the software e-stop, where that second pole of the e-stop goes straight to the board and the pins read the state of it and go, okay, has this been pressed? If it's been pressed, we're going to just call an emergency stop in RepRap firmware. So we think it's a good idea, and it's not going to cost anymore because the relay's still there. But whether or not we have to do it, whether or not that relay could be useful in more ways outside of being redundant, is a decision that we need to make. I'm still leaning more towards the let's make it redundant, but it's an ongoing discussion in the team at the moment.
Yeah, and there's multiple auxiliary ports as well,
Yeah,
tied to the MOSFETs. So I would think that it would be easy enough to use one of those to trigger a relay or a solenoid for other uses.
yeah. So long as you're running, I think this is the case. So long as those are DC inputs, that's fine. Those MOSFETs are fine to switch those DC inputs. The relay is good because you can also switch AC with it.
Yeah.
And there are some times where you would want to switch AC directly. But at that point, there's the argument to be made where you can just use the MOSFET ports to trigger an external relay board.
That's what I was
Um,
thinking. So,
yeah,
you know, a more advanced user could set up an external relay controlled via MOSFET to be able to do
yeah,
AC
yeah,
switching rather than
yeah.
relying on the onboard relay for that.
Yeah, I would say it does add complications and it does add layers of potential safety issues when you've got so many things that could have a failure state. But in reality, the likelihood of failure for the likelihood of failure that would cause an endangerment to human life is very low, and it's very much up to the user how much they're willing to put themselves at risk at that point if they're adding stuff that um, we haven't said is okay to use.
Yeah. Well, and in that, I would think that utilizing the onboard relay for an absolute, belt and braces safety routine is a better use of that resource than a potential failure of a MOSFET controlling a relay, which is controlling flood coolant or,
Yeah,
a mist cooling system.
I agree with you. I agree with you. It is worth people knowing this, so it's a bit of information. If people do want to go down that route, understand that MOSFETs and SSRs typically fail closed. Right. The reason we can get away with it with SSRs and 3D printers is because they're in series with thermal relays, and those thermal relays will blow. So if the SSR did fail closed and your bed was heating up, that thermal relay would be able to um, break that connection. That's why it's fine in 3D printers. In CNC, not so much.
Yeah. Yeah. So there's a lot of options there. Kind of moving on through looking at the board, there's 8 end stop ports.
Yep.
We've got dedicated tool setter and probe ports. Oh gosh, there is so much on this board. Let's see. Yes, there's all of so there's 3 aux ports.
There are four, I believe.
Well,
Uh, the mist and coolant are technically aux ports, so there's actually five.
yeah, that would be
They work
5.
the same way. They've just dedicated just the silk screen that's on them is dedicated to them being mist and coolant. You could use them for
Gotcha.
whatever you wanted to.
Um, yeah, and the board does come with looks like an an Espressif ESP32, which would be running the the web interface as well as providing Wi-Fi for the board.
Yep. And for those of you who want to run a hardwired connection, you can take that ESP32 out, and BTT does sell um, a module for Ethernet. So if you wanted to do a hardline connection, um, you can do that.
That is good to know, because that might be happening for me at least. Um,
That's fine.
well, as it stands now, I have the Mellow board running as excuse me, I don't know what's going on with my voice today. The Mellow board is running as an access point, and then
Yeah.
I have a standalone Raspberry Pi connected to a touchscreen just on that Wi-Fi. But if I can hardwire the control board in, then that would simplify a lot of things that I was trying to do. Because ultimately,
Yeah.
I would love to have the mill hardwired to my network just so that I can more easily, send my G code from my main machine.
Yeah, makes sense. Makes absolute loads of sense. I'm going to be running. I run a BTT Pad 7 as my touchscreen interface on my CASA. And once that module arrives, I'm going to be running directly from the Ethernet port at the back of that screen into the into Sila, just because I want the you don't, most people can get away with Wi-Fi. There shouldn't be any issues with it, but I just like that extra little bit of safety on top of it, where I know that no one can connect to it. Funny thing was actually when we were setting up for Smurf, I'd managed to get Sila working 2 days before Smurf, and we were rushing to get everything ready and configured. That I never changed the default passwords for it. So when we got there and set everything up, I had Steve and Nero come up to me saying they couldn't figure out why their phones weren't getting any internet. It's because they connected to my machine, thinking. So yeah, internet safety is a thing, folks.
Yeah.
Think about it. Make sure you change your passwords.
Well, there that is definitely a concern. Um,
Yeah,
my my rationale for using the built-in access point was simply latency, because I found
yeah,
having the Raspberry Pi connected to my network when I had the flyboard on my Wi-Fi network, you've got
yeah,
the wireless latency of from the mill to the router to the Pi and back. So there was enough lag that it was kind of uncomfortable for me if I was doing travel moves or, anything like that. So yeah, having that hardwired, even if it is just in a peer-to-peer system like you're talking about, would be nice.
yeah,
But then it would also be kind of interesting. I haven't looked into what I would need to do to be able to set up multi-homing on the Raspberry Pi, because at that point I could have one network that would be Ethernet from the mill to the Pi, and then be
yep,
able to put the Raspberry Pi on my Wi-Fi network that I
yeah.
could,
I
screen
I do that
share.
same. I do the same. I do exactly what you're talking about. I don't screen share it, but because DWC is a network interface. As long as you, I my com- the computer that I use in my workshop is connected to both Ethernet to for my Wi-Fi connection and then to the access point for Milo. So I can send Fusion files directly from this computer and have them show up in DWC on the Pi quite easily without having to do any extra setup.
Yeah, once I get to that point, I'll have to play around with it,
Yeah,
because I have a network switch right where the Milo normally lives when I'm
mm,
not shooting video, which seems to be all the time now.
yeah,
So yeah, overall, it looks like an incredibly well spec'd board. There's also, so you do have the capability of using external stepper drivers, not just the 2160s that are on here.
yeah.
Um, so
I
if
believe so.
Yeah, so I think, see if I can, I think it's this
The
row
ports at the
of
top. Yeah,
JSTs. Um,
those are all step direction signals. So
yeah,
you could even run servos if you really wanted to.
yeah. So the idea
Like
is
the
this is a board that's not just specifically for the Milo series, that it
Yeah,
could be incorporated in a number of other projects.
yeah, and that's kind of our theory with the whole of the electronics as well. So the electronic setup that we're running for Milo is going to be the same that we run for Atlas. It's going to be the same that we run for any other CNC machines that we build in future that we might have. It's all going to be the same. You'll never have to change it from here on out. And in terms of upgrades for something like a fourth axis, which we do think we're going to be working on for Milo and for Atlas, it should just be an extra tutorial on top of that. So just an extra wiring diagram just for those specific bits. There shouldn't need to be a change like we had from V1.5 to to Sila, sorry, from the CDY to Sila, going forward. It should just be good enough.
So let's take a minute and talk about those wiring changes because
Yep.
in our earlier conversation before we started doing this, you know, it sounds like to truly get the most out of this, this isn't as simple as take out the CDY board and drop in the Sila. There are other improvements that you want to make.
No, yeah, you're completely correct there. To take best advantage of the Sila, you really want to be running the motors at 48 volt and above, and that will double the top feed rate that you might have had on your V1.5. Um, so, and it also means that you get the added safety of being able to cut the motor voltage to come to an emergency stop separately to the MCU voltage, and then you can have a perfectly safe shutdown system. So the way we're going forward with it is we're recommending a 48 volt power supply. Feel free to use 24 volts still if you want to, but you need a second smaller power supply. Doesn't need to be more than say 20, 30 watts. HDR 30s, I believe, sorry, HDR 30s from Meanwell will be more than enough. You can run them at 24 volt or 12 volt. 24 volt has a bigger advantage because it means that things like end stops have more of a resistance to EMI issues. And you can technically run higher, but because we're using inductive end stops on V2, they max out at 30 volt. And they run off of the V MOSFET voltage. So you will need an extra power supply. You will need a contactor, and the contactor is just a big boy relay. If you know what a relay does, you know what a contactor does. And that does the actual cutting of power to the 48 volt supply and to the VFD supply.
So you're
You never
using
want
that.
to. Sorry, go ahead.
No, I was just going to say, so you're using that contactor to actually cut the mains input, not the
Yes. Yeah.
output. Okay.
Yeah. So you never want to cut the output of a VFD, for example, because it can cause really bad issues, and there's a potential for um, the live spinning mass, the mass of the spindle to keep that spindle running and cause burnout issues in the actual wires and cause a fire. So you never want to cut the spindle side, but you're safe to cut the AC inside to a VFD. And if you're cutting the AC inside to the VFD anyway, you may as well double up, and instead of having to get a separate contactor for the DC side of things on the 48 volt supply, you just cut the AC to the 48 volt supply as well, and then that will also obviously cut the DC supply to the motors. So it's simpler on a wiring front. You need to have less individual setups, and the simpler we can get the wiring, the safer it can be.
Okay. And is that going to be part of a potential 1.6 upgrade?
Yeah. So V1.6 was a decision we made at Smurf, actually, because for the majority of people, they know Milo. They've known Milo for about a year. We've been going on 4 years now. Yeah. I actually think we're over 4 years old. V1.5 has been a thing for over 2 years, and the V1 series of machines of Milos have been going for that full 4 years. Right, the first one you could build was V1.3, then there was V1.4, then there was V1.5. So to us, we've been supporting that old platform for quite a long time. And there are some small issues that we've had from whether or not it's been from the fact that I only started doing CAD when I started doing Milo. So there are small inconsistencies in the CAD file. There are some rounding issues from when we've moved from one CAD software to another, from just small things like that. They've not affected the machine V1.5 badly at all. It's still a completely usable machine, but there are just some small oddities and rounding errors and things like that. So we decided when we started on V2 that it was going to be a ground up redesign. And when we went to Smurf, obviously people aren't happy that they've just bought a machine and it's not going to get any support, right? So we made the decision at Smurf that we were going to support V1.5 for at least another incremental upgrade. So V1.6 is going to get the majority of the upgrades and choices that you can have on V2. There's going to be a few things that we just can't port over. Things like the extra build volume in the y-axis is just not possible, because you need to change the way the extrusions are laid out entirely. So what we sat down and we went, what can we salvage from V1.6 from V1.5 to put in V1.6, and we managed to salvage most of the structural components. Because the electronics are going to be pretty machine agnostic, we're also taking all the electronics with us, and we're going to recommend the removal of the basement part of V1.5. You can actually see my old V1.5 behind me. So we're going to get rid of this basement part here. And we're going to recommend just using one of the NEMA ABS enclosures, or probably design one for those of you who want to print an enclosure for it. And that can be moved away from the machine where you're not possibly going to get your fingers trapped in a spindle or anything like that. And that's also going to come with the benefit of having the cables long enough to begin with to be able to lead them into CASA. So if you did want to transition from having that little ABS box, that little NEMA box that's mounted on the wall, to having a full enclosure, you should be able to do that without having to lengthen a load of wires, which people will have to do from V1.5. So there's lots of benefits to it. There's some downsides to it. There's some irritations because this community has been used to having all their electronics enclosed in their machines for quite a while. That was kind of why we went this way with V1.5. But also having all these extra extrusions it's an extra expense at the end of the day as well, which we could easily put towards other parts of the build to make the other parts of the build a little bit cheaper.
So my understanding of Milo V2 is we're looking at a lot of changes to the motion system I mean, basically in terms of, and correct me if I'm wrong, please, but looking at ball screws for V2.
Ball screws are an option. So
Okay.
I've talked about this on stream before. I talked about it on stream yesterday, actually. Ball screws are an option. They work with the idea that everything else can stay the same in Milo and Miley V2. But the only thing that you need to change is a single printed part to change between either TR8 lead screws or 0802 ball screws. Now, TR8 lead screws have a pitch of 8 millimeters. So for every full 360 rotation, they move 8 millimeters. And on the ball screws, the 0802, they have a 2 millimeter pitch, which means they're technically more accurate. They have a higher resolution. But the trade-off here is you get a lot higher resolution, but your feed is now 1/4 of what the TR8 lead screws are. So in a machine like Milo, because it's such a lightweight machine, you want to practice HSM, high speed machining techniques, a lot of the time. So that means half the engagement of a typical cut, but twice the feed rate. And that way you get the same amount of material removal rate, but your um, but your tools and your machine that has less rigidity can do those cuts much easier. The ball screws are there for people who want them. They're a bit more of a baller option, but you're losing the ability to do as fast a high-speed machining job. And when you're talking about a machine like Milo, where rigidity is, again, like I said, a big issue, the deflection that you get from tooling is going to work against any resolution bump you get from the ball screws. So ball screws are an option. They are something that if people really want them, they can put them in there. I don't know a single member of the team who wants to go ball screws versus lead screws. There's also a benefit to, there's a few more like quality of life benefits to ball screws. Ball screws have very, very little backlash. But if you're managing the backlash properly, like we do with the anti-backlash nuts on Milo, you don't need to worry about the backlash anyway. Ball screws are a lot easier to install because it's literally just slide it on, tighten a few nuts. Whereas on the new nut block system that we have on Milo V2, because it's a spring preload system, so that spring preload system is a little bit harder to set up, but once it is set up, you're good for a millimeter of wear on the lead screw before you actually need to replace it. And by that point, you'd probably be replacing the screw anyway. So there's advantages, there's disadvantages. Personally, I would actually stick with the TR8 lead screws.
Okay. So where I was going with that question is because I had assumed that V2 overall was potentially a more expensive machine. You know, is there a plan for there to basically have to support 1.6 and 2 simultaneously, or is V2 just the future as far as Milo?
V1 ends with V1.6. Because there's too many structural changes to V2 that we made that we just couldn't backport to what we currently have hardware wise on V1 point on V1.6. Sorry, V1.5, V1.6. Those two. And as much as I hate the fact that there is no backwards compatibility there, we have been supporting it for 4 years. You can't always have stuff that's backward compatible. It was a tough pill to swallow on my end. I actually had to be convinced by the guys that it was probably the better thing to do on a couple of occasions. And I totally agree with them that sometimes you need to make changes to make things better. V2 will have an equal amount of support or more than V1 did. And hopefully we get to the point where V2 can just get to a point where there's no real improvements that we need to make for it. Some kind of looking at like a V2.4 from Voron, there's not really much you can do. The V2.4 hasn't really had many releases because it's as pretty much as good as it can get, conceptually wise at least. There's obviously going to be small revisions here and there, but hopefully our V2 will get to that point. But yeah, V2's got a lot going for it. I think it's a lot easier to tram. It's a lot easier to use. It has inductive probes, so you technically get a better homing system because the end stop switches could be a bit hit or miss sometimes on V1.5. It's a lot stiffer. Everything's direct drive. You can choose between ball screws or lead screws. You can choose between Milo and Miley, and whether or not you want more uh, build space and build area, or whether or not you want a stiffer machine, but you lose build area. There's lots of cool things that are coming to the two.
Cool. Yeah, and certainly I understand, 1.6 is kind of the terminal release of the one line. I just didn't
Yeah.
know if there was basically like, well, at a lower price point, you could build a 1.6 versus a more advanced machine in the version 2.
Oh yeah, yeah. You probably could. Um, yeah. V1.6 would probably be cheaper. Um, the just just from an amount of materials wise, right? There's less in V1.6 than there is in V2, so you're going to have that as an advantage. There's no reality where it won't be cheaper than a V2, and a V1.6 is still going to be an absolutely valid machine to build if you want it. So yeah,
Yeah.
in that case, yeah, you're totally right.
All right. And then we've got the Miley that we're looking forward to seeing.
Yeah. So Miley shares the same z-axis and y-axis as Milo, but you can choose whether or not you want the actual fixture plate to move. So the bed stays stationary, and the fixture plate moves on top of the bed. Like I said earlier, it goes from 350 in the x direction on Milo to 310 on Miley. But that setup means that you get to save 200 millimeters on your enclosure size. So for those of you with slightly smaller shops, you can run that, and you could probably get away with just putting an enclosure on the fixture plate itself, like they do on some manual machines. You can't really do that on Milo, just because of the way it's set up. Uh, and it's going to be technically stiffer. You do lose a couple of benefits. One of them being the two dead zones on the side. On Milo, because the table doesn't go all the way from one end to the center of the cutting area, there's a dead zone on either side of it. And those are really good for when you want to mount things that are external to the cutting area. So if you want a fourth axis where the body of the fourth axis sits out of the tool of the build area, you can do that, then have the actual rotational bit in the build area, and then you have a lot more space for whatever you want to build, whatever you want to make. If you did that on Miley, you would have to put it dead center in the build area itself, and you would eat into a lot more of your workable area. But you do get the benefit of it being a much, much stiffer, much more rigid setup on Miley than you do on Milo itself.
Yeah. And then finally the Atlas, which is a completely different machine layout.
Yeah. So for those of you who have been in the industry before, you may have heard of a Datron Neo. Have you heard one, Alan?
It's vaguely familiar, but
Yeah.
not totally familiar with
So
it.
Datron, I think they're a UK company. They're a CNC manufacturing company. They came out with a machine called the Neo, and the Neo is a big fixed gantry style machine. Fixed gantry in the 3D printing world, it would be your classic bed slinger style. Um, and that fixed gantry machine uh, has the enclosure completely built into it, and it will fit through a normal door. It'll fit through a standard size door in the UK and the US, um, and everything's self-contained. Everything's built into it. It's an amazing machine. Atlas is following that kind of thinking. So Atlas is going to be twice the build area of the V2 of V2 Milo, exactly twice the build area. It's going to be able to fit through a door. It's actually technically going to take up less space than a CASA enclosure will, because of the way a fixed gantry machine is set up. You can get away with a thinner machine, but it is also going to be a lot taller. So it's going to go from the ground up to whatever the operator's height is going to be. So maybe 1.5 meters tall. And it's going to be around about 150 kilos of machine. So it's one of those things where um, it's going to be more towards the prosumer market of people who want to build it. We're not too sure if LDO could supply a kit because that's a lot of heft in a kit. But it's going to be a beast. It's going to be something that you could probably do a lot of light manufacturing on. Excuse me. Sorry about that.
No, it's all
I'll
right.
turn my phone.
Not to worry. So yeah, it's really not something that your average hobbyist is just going to jump into.
It depends because we're actually looking at the self-sourcing side of this. Now, because it's a much bigger machine, we don't have to deal with a lot of the drawbacks that you're getting from Milo, right? Milo is trying to fit a big thing into a small thing, right? So there's lots of tricks and whatnot that we have to pull to get it working. Atlas, because of its size, means that we can use more easily available materials. So things like 1204 ball screws, you can buy cheap ones for nearly half the price than if you bought the smaller ball screws that we have spec V2 for. Things like extrusions, rails, HDR20 rails are cheaper than MGN15. So from a self-sourcing side, you might be able to, it'll definitely be more expensive, but I don't think it'll be that much more expensive than a V2 will be. But then you also have to realize that this is going to be a machine that's going to have air plumbed into it. It's going to need a lot more maintenance. It's going to take up a lot more space. Technically, take up more space, and so from a self-sourcing point of view, it might not actually be a bad choice compared to Milo for people from a purely cost perspective.
Okay. It'll be interesting to see how that plays out.
Yeah, the biggest issue that we've seen is more that people there's less people who want to self-source. So even if it's cheaper, the self-sourcing route just is less popular.
Yeah, I definitely feel that
Oh yeah.
because
So
the thought of self-sourcing a printer at this point is just like, what? Why won't someone just do a kit, please?
we're thinking at some stage in future that we might be doing a printer. We might be doing a printer that has an option for being fully assembled.
Interesting.
But that's very, very, very far off in the future.
So yeah. Well, thanks for taking some time to talk through the new Scylla board. Happy that I picked up mine. I think I'm probably going to wait until I can get my hands on more of the parts for the 1.6 style upgrades. And
Yeah,
also, honestly, I am going to be building Casa this summer, so
yeah,
I'll probably just wait until I relocate all the electronics into the enclosure,
yeah.
rather than doing it twice.
Makes total sense.
Yeah,
I would do the exact same. I only just moved my V2 back inside Casa after Smurf yesterday. So
yeah, yeah. Unfortunately, you normally stream when I'm at the shop, so I can just
ah,
pop in and say hello, and then back to work.
yeah, yeah, that's fair. That's fair. Well, thanks for having me around, dude. Thanks for listening to me natter for
Oh,
however long it's
please.
been.
No, no, I appreciate it. It's always good to catch up and talk about what's happening with Millennium Machines.
Yeah, there's a lot of stuff going on. It's hard to keep track of it sometimes.
Well, that's why I like to check
No
in. So thanks again, and I will talk again with you soon.
worries. Yeah, cheers, dude.